Hi all. In previous video we saw about types of curves in computer graphics. So now we are going to see about Bezier curves, one of the type of curves in computer graphics in the unit 5 of computer graphics and visualization course. Let's move on to the video. So what is the Bezier curve in computer graphics? So the definition of Bezier curve is the Bezier curve is defined using a parameter T. Bezier curves are functions that produce continuous smooth curve controlled by the mathematical expression. So mathematical expression in the sense we are going to control or develop a smooth curve with the help of the control points. So they allow designers to describe curves in terms of control points which do not necessarily lie on the curve but defines its shape. Here the control points is not going to necessarily lie on the curve but it is going to define the shape of the object. So let's see about the inventor of this Bezier curve. So Pierre Bezier, who is the inventor of this Bezier curves, which is established in the year in 1990s, a French engineer. He is a French engineer at Renault, introduced this Bezier curves to streamline automobile body design. So simultaneously, Paul de Casteljar at Citroën developed similar work, but Bezier popularized the curve through publications. There are two inventors of this Bezier curve. One is Pierre Bezier and the other one is Paul de Casteljar, but the Bezier popularized with the help of their publications. So next, usage of this one. It is widely used in vector graphics, animations and font design. So in vector graphics, so it can be found in Adobe Illustrator, CorelDRAW, Inkscape, etc. In animation, it is going to define motion paths or shape morphing. So in fonts, PostScript and two true type fonts are used Bezier curves to describe their presence. So Bezier curve application cycle. So here first we are going to design the curve first. So create smooth curves for various application. Next we are going to apply that in graphics. The next one is refine design. So we have to improve curve design based on the application feedback, and then we are going to implement in fonts. So the next one. So mathematical foundation of the Bezier curves. A Bezier curve can be given as defined using parametric equation, which is completely based on the time t. So 0 less than t less than 1. So this continuous equation going to lie between the variables 0 and 1. So Bernstein polynomials are, these polynomials serves as a basic functions for the Bezier curve. They are going to ensure a smooth and continuous interpolation over the intervals. So what do you mean by interpolation is, for example, I'm giving a real-time example. Suppose you know the temperature at the time 2 p.m. and what is the temperature at 4 p.m. So with the help of these two temperature, we are going to calculate the temperature at 3 p.m. So this is called interpolation. So next one is control points. So the geometry of the curve is defined solely by the position of these control points. So moving a control point dynamically is adjusting the curve. So types of Bezier curves. We have three types of Bezier curves. One is linear, second one is quadratic, and third one is cubic. So what is linear is, it is defined by the two control points. So if it has two control points and it is forming a straight line, then it is called linear Bezier curves. The next one is quadratic Bezier curve. So what is quadratic Bezier curve is, so it is defined using the three control point. The curve bends once and is computed by the blending two interpolations. So common in basic shape drawing and simple path animations. So this is about quadratic, and the next type is cubic. It is defined by the four control points. So it is going to offer flexibility for modeling complex curves. So it is most commonly used in graphic design software due to its balance of control and complexity. So what type of curve should be used for which design? So linear. So this linear can be used for the basic shapes, and quadratic offers one bend with three control points and it is ideal for gentle curves. So cubic allows for complex curves and it is best for intricate designs. So the next properties and applications of Bezier curves we are going to see one by one. So what do you mean by, we are going to first see about the property called affine invariance. So what is affine invariance? If all the control points are transformed, translated, rotated and scaled, the resulting Bezier curves undergoes the same transformation. Then the next property is convex hull property. What is convex hull property is, the entire Bezier curve lies with the convex polygon formed by its control points. So this aids in bounding box calculations and rendering optimizations. So control points, what do you mean by control point is, it is going to give the smoothness to the curve. The degree of the curve is defined or is identified with the help of control points. For example, if the curve has 4 control points, then the degree of the curve will be 3, which is 1 minus the control points. So sorry, the control points minus 1. So the next property is endpoint interpolation. So the curve always begins at the first and ends at the last control points. So this is called endpoint interpolation. The next one is continuity. To form an object, we need continuity in that one. So next, characteristics. So what is meant by characteristics of Bezier curves is, the Bezier curve has the following properties. One is smoothness, the second one is local control, third one is recursive definition, and the fourth one is parametrization. So where this Bezier curves will be used? So the applications of this Bezier curves are computer graphics, animation, font design, CAD, as already stated. So this is used by Bezier in the automobile design itself. So this is one of the real-time application of this Bezier curve. So the next one is de-Casteljaus algorithm. We saw that 2 people designed this Bezier curves, but the Pierre Bezier made this Bezier curve popular with the help of his publication. So let's see about this de-Casteljaus algorithm also. So it has a recursive construction, so a geometric method for computing Bezier curves by recursive linear interpolation. So we have to initialize the control points. So start with the set of control points, then we have to follow the linear interpolation, compute new points between the control points. So here next we are going to iterate the interpolation, repeat the interpolation until one point remains. So next we are going to get the final point. So the remaining point is on the Bezier curve. So this is about the de-Casteljaus algorithm.